These are the notes for section 7.3. We've been learning about multiplying and dividing monomials, and now we're going to learn about something called scientific notation. And you're going to see inside of scientific notation, you're going to find those monomials that we've been multiplying or dividing. You should have your textbooks open to page 416. I would suggest using your textbook to kind of follow along with the notes today so that they can answer any questions as far as definitions or key concepts that I don't go over in today's notes. So scientific notation is pretty easy to understand. It's hard to write an actual definition for it, so I'm just going to have you take a look on page 416. It gives us that yellow scientific notation, and it says it's a really easy way to write really, really big numbers and really, really small numbers using exponents with 10 as your base. And when they say really, really big or really, really small, they might mean like the distance to the moon or the speed of light, or if you're talking about really, really small, maybe the size of a germ. Things that you can't see that could because they're so big or so small. Writing out those numbers, like that distance to the moon, that's huge. So writing that out, especially if you're doing like a word problem, would get really tedious having to write all those zeros every single time. And so they give you something called scientific notation for an easier way to write that number. We're going to just say, for our definition, an easier way of writing really big and really small numbers using exponents and a base of 10. And I think you've seen scientific notation before, so this should be a review. Here's the steps to writing something from standard form to scientific notation. Before we get started, I want you to understand that those are the two things we're going to be talking about today: standard form and scientific notation. Standard form is just the number written out as you normally would write it. Scientific notation is the one with exponents. So the first thing we're going to do is we're going to take our standard form number and write it in scientific notation. The step: move the decimal point until it is to the right of the first non-zero number. The second, note the number of places, n, and the direction that you move the decimal point. If the decimal is moved to the left, the number is positive. If the number is moved, or the decimal is moved to the right, it will be negative. You write it as a number times 10 to the number of places that you moved it, or the number times 10 to the negative number of places that you moved it. Remove all unnecessary zeros. That will make more sense when we do an example. So on the next page, we have the number 201 million. And I know if I have 201 million without a decimal, that means the decimal place is at the very end. And I'm going to move it to the left. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it moved 8 times. Now, the reason I moved it to behind the 2 is it's supposed to be on the first right of the first non-zero number. 2 is the first non-zero number, and there can only be one number on the left-hand side of that decimal. So I'm going to rewrite this as 2.01. I'm removing these zeros because they're unnecessary. I have to keep this 0 in there because it's between this, so 2.01 is different than 2.1, so we have to keep that 0 in there. Times 10, 10 will always be your base. Now we moved it to the left 8 places. We know that the exponent is going to be 8. Now will it be positive or negative? Take a look at your notes. It says we moved it to the left, which in step 3, if you move it to the left, it stays positive. Okay? That's your answer. Now let's take a look at the next one. I have 0.000051. I'm going to move it to the right. 1, 2, 3, 4, 5. I have to move it until it's behind that non-zero number. And it becomes 5.1 times 10 as your base. And I moved it 1, 2, 3, 4, 5 times. And I moved it to the right, so it will be negative. Okay? I want you to go ahead and try those next two on your own, and pause the video, come back when you're ready. So I have 68,700,000,000, and I know that my decimal is back here, so I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 places. So I get 6.87, remove the unnecessary zeros, times 10 to the positive 10 because I moved it to the left. Now I have 0.000725, so I move it to the right 1, 2, 3, 4, 5 places. I have 7.25 times 10 to the negative fifth because I moved it to the right. Okay, turn to the next page. So in those examples, we were taking the standard form and writing it in scientific notation. We can also work backwards and take scientific notation and rewrite it in standard form. So first thing you do is if you have a to the times 10 to the nth power, if n is positive, you know you're going to move this way, and if it's negative, you'll move to the left. Sorry. So if it's positive, you move to the right, and if it's negative, you move to the left. So it's the opposite of what you did when you were writing standard to scientific. Then you insert necessary zeros and decimal points and commas for place value. It's really pretty easy. So let's go ahead and take a look. I have 6.32 times 10 to the 9th power. So I'm going to take 6.32. It's positive, so I'm going to move it to the right. I'm moving it to the right 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where my decimal will end up. Now I have a bunch of these empty bubbles. I'm going to fill each of them in with a 0. Okay? Now I have 6, 3, 2, 1, 2, 3, 4, 5, 6, 7 zeros. Okay? That's fine. I had a decimal place there, but since I don't have anything behind it, I can just let it fall off. And I'm going to place my commas every 3 places like we're supposed to. So I get 6,320,000,000. Okay? Let's take a look at 9.03 times 10 to the negative fifth. I have 9.03, and I'm moving it 5 places to the left because it's negative. So I'm going to take it and I'm going to say 1, 2, 3, 4, 5. My new decimal will be there. And I have to fill in the necessary zeros because these are 4 empty bubbles. Okay? I also know that my decimal place is going to stay there, so I'm going to put a 0 out front, even though there's no bubble. So I have 0.0000903. Okay? Go ahead and turn the page. Now, you aren't going to do any of those examples by yourself. I trust that you can do them. We'll practice them on the actual homework. Now we know that we've been multiplying and dividing monomials. You can actually use multiplication and division, just like we did before, on scientific notation. So this is 3.5 times 10 to the negative third times 7 times 10 to the fifth. We would never want to do that without a calculator when we had it in standard form. This is going to make it a little bit easier though. This is the same thing as 3.5 times 10 to the negative third times 7 times 10 to the fifth. I'm going to rewrite this using the commutative property, and I'm going to make it 3.5 times 7 times 10 to the negative third times 10 to the fifth. And I'm going to group these. I'm going to take 3.5 times 7. I will use a calculator for that. 3.5 times 7, and I get 24.5. And then I'm going to take that 10 to the negative third times 10 to the fifth. Now, remember when I have the same base and I'm multiplying them, I just add them. So I have negative 3 plus 5 gives me positive 2. So I have times 10 squared. That makes it a whole lot easier than if you were using standard form. Now let's go to the next one. I'm going to regroup this. I'm going to say it's the same thing as 6.5 times 8.7 times 10 to the 12th times 10 to the negative 15th. So 6.5 times 8.7 gives me 56.55 times, now I have 10 to the 12th and 10 to the 15th. They have the same base. 12 plus negative 15 gives me negative 3. Okay? You do not need to write this as 1 over 10 to the positive third because in scientific notation, we're allowed to have those negative exponents. So just leave it as is. Okay? So I want you to try number 3 by yourself, and then we're going to talk about dividing them in the next example. Pause the video, come back when you're ready. So I have 1.95 times 7.8 times 10 to the negative 8th times 10 to the negative 2. So 1.95 times 7.8 gives me 15.21 times, now I have 10 to the negative 8th and 10 to the negative 2, add them and I get 10 to the negative 10th power. Okay? Turn to the next page. Same concept when you're dividing. You're going to take these two numbers and divide, and these two numbers and divide. So I'm going to just group them. I'm going to say 3.066 divided by 7.3 times 10 to the 8th divided by 10 to the 3rd. So I take 3.066 and divide it by 7.3, and I get 0.42 times, now 10, I have 10 to the 8th and 10 to the 3rd. I'm dividing, so I subtract, so I get 10 to the 5th power. It's positive because the 8 was in the numerator. Okay? Go ahead and try those next two examples on your own. Pause the video, come back when you're ready. I'm going to take 2.3958 divided by 1.98 times 10 to the 3rd over 10 to the 8th. So 2.3958 divided by 1.98 is going to give me 1.21 times 10. Now 3 minus 8 gives me negative 5. On the next one I have 1.305 over 1.45 times 10 to the 3rd over 10 to the negative 4th. 1.305 divided by 1.45 gives me 0.9 times 10. Now 3 minus a negative 4 is the same thing as 3 plus 4, so to the positive 7th. Okay? That's actually the end of the notes. So go ahead, take a look at the homework, finish the 7.2 homework, and I'll see you tomorrow.